Hello everyone. In this demo, I will demonstrate the application of uh, automated model design based on the RD-Agent framework in the medical scenario. To showcase the model design capabilities of RD-Agent beyond the financial domain, we have chosen to test the RD-Agent's performance on electronic health record in the medical field. We used the publicly available EHR dataset, MIMIC3, and extracted a time series prediction task. Specifically, in this task, we aim to predict whether a patient in the ICU will develop acute respiratory failure, shortened for ARF, based on the first 12 hours ICU monitoring data. For this task, we use AUROC score as the evaluation metric, which is area under the receiver operating characteristic. This is a commonly used metric for binary classification. Now let's look at the optimization process of RD-Agent. Let's just focus on one loop for now. We can see at each iteration, the framework first proposes a hypothesis. Based on this hypothesis, the framework further proposes a model structure. We can see including the description, formulation, and variables. This constitutes the proposal research process. After this process, we can move on to the development phase, where we prompt the large language model to generate the code for this model structure. We can observe that we have multiple evolving rounds. At each step, the LLM attempts to write the current model's PyTorch code and then checks if that's correct. If it's correct, we can accept the results. If it's not, then we will try the next attempt. We can observe that the LLM generally needs 1 or 2 rounds of evolving to finally generate the correct code. Furthermore, we can observe this generated code on the right corresponds correctly to the model descriptions on the left. After completing these 2 steps, the LLM also provides feedback, offering the interpretability of this result and also helps in generating the next hypothesis. Okay. After the detailed explanation of a single round, we can see the whole trace. When reviewing this trace, we can see we run 4 rounds in total. Initially, RD-Agent proposed a model that combines CNN and LSTM to capture both spatial and temporal information for our time series data. We can also observe that for each round, the RD-Agent integrates medical knowledge with machine learning knowledge, considering both for generating a better hypothesis. During each iteration, RD-Agent modifies the hypothesis, such as introducing additional attention mechanisms, also the batch normalization, or replacing the LSTM with the more advanced GRU structure. Through these model structure optimizations, we can achieve performance improvements in this medical prediction task. Additionally, we can see that the knowledge outputted by RD-Agent in each round is changing accordingly, reflecting an enhanced understanding of the current task by the LLM. Thank you for watching, and we also encourage you to apply RD-Agent to more machine learning scenarios to explore the potential of large language models in automated model design.